So for this problem, you are given op-amp, and we're going to consider this op-amp as ideal op-amp, and you are asked to find the transfer function g of s, which is given by v out over v in. Before we tackle this problem, we see here's the parallel component, and then we have the series component. And in the parallel component, I'm going to call it as a Z1. And then series component, we're going to call it as a Z2. So for the Z1, 100K is parallel to 2 microfarad. Let's convert this into S domain and combine them. So the Z1 equals, if they are parallel, we need to multiply 100K times 1 over SC, which is 2 micro, over add 100K plus 1 over S times 2 micro. Now, for the numerator, we have 100K over 2S micro, and the denominator, we have 100K plus 2S. The micro is 10 to the negative 6. I'm going to take it to the numerator. Then we have a 10 to the positive 6. I'm going to write one more time 2S micro, and then we want to make common denominator as a 2S. Then 100K times 2S plus 10 to the power of 6. This equals 100K over 2S micro times, I'm going to flip this because we are taking to the numerator. That means we need to have reciprocal of the denominator, and that is 2S over 2S times 100K plus 10 to the positive 6. Then we have 100K, actually 200Ks as a numerator, and then we have a 2S times, we're going to multiply this micro here and here, then 2S times 0.1, because there are 5 zeros in here, plus micro is 10 to the negative 6, that'll be positive 1. And we can divide top and bottom by 1 over 2S. Z1 is now 100K over 0.2S plus 1. And for the Z2, they are series, so we need to add those two, or 400K plus 1 over SC, which is 4 micro, and that is 400K plus 1 over 4S times 10 to the positive 6. And we can have the common denominator. That is 400K times 4S plus 10 to the power of 6 over 4S. And that is 1600Ks plus 10 to the power of 6 over 4S. Now we have Z1 and Z2, and I'm going to redraw this circuit using Z1 and Z2. It is an ideal op-amp. We need to first assign the direction of the current. All the current go through this 50K ohm is going to go here and here, because in the ideal op-amp, these current going into this op-amp, we assume that they are all 0. And for the bottom portion, we have the current goes in here, goes down. And then we're going to say this is V1. If that is the V1, this has to be V1 as well, because that's how we analyze the ideal op-amp. Then entering 0 minus V1 over 50K equals leaving V1 minus V out over Z1. That's the first equation. And now we're going to cross multiply, and that will give us negative Z1 V1 equals 50K V1 minus 50K V naught. We want to isolate V1 because our transfer function is defined by V out over Vi. So we don't need V1. So we're going to have first equation in terms of V1, and we're also going to have the second equation in terms of V1. We're going to let them equal to each other so that we don't have V1 in the equation. So then we have a 50K V naught equals 50K plus Z1 times V1 Therefore, our V1 from the first equation is going to be 50k V naught over 50k plus Z1. Our second equation is going to be from the bottom. Entering V in minus V1 over 200k equals to leaving V1 minus 0 over Z2. Similar way, we're going to cross multiply, then V in Z2 minus V1 Z2 equals to V1 times 200k. Now V in Z2 equals, we're going to factor out V1, 200k plus Z2 times V1. V1 equals Z2 V in over 200k plus Z2. So now we have two equations in terms of V1. We're going to use these two. Then we have a 50k V naught over 50k plus Z1 that equals Z2 V in over 200k plus Z2. If you divide both sides by V in and move this portion to the right hand side, we're gonna have V out over V in equals Z2 over 200k plus Z2. That's the right hand side term. And the left hand side term, we're gonna take the reciprocal of that, which is 50k plus Z1 over 50k. Now, from here, we have a 200k plus Z2, and that is 200k and Z2, 1600k s plus 10 to the 6 over 4s. And that is, if you have a common denominator as a 4s, we're going to have 800k s plus 1600k s plus 10 to the power of 6. That is 2400k s plus 10 to the 6 over 4s. And also, we have 50k plus z1, and that is 50k plus z1. We found that as 100k over 0.2s plus 1. Again, we're going to have a common denominator 0.2s plus 1, and then we have a 50k 0.2s plus 1 plus 100k. And if you simplify a little bit, we have 10ks plus 150k over 0.2s plus 1. So our transfer function v out over v in equals to z2, and that is 1600ks plus 10 to the power of 6 over 4s times 1 over 200k plus z2. So we calculate 200k plus z2 here, but this is the denominator, so I'm going to multiply reciprocal of this, which is 4s over 2400ks plus 10 to the power of 6. And then 50k plus z1, that is 10ks plus 150k over 0.2s plus 1, and 1 over 50k. Now let's put them all together. We have 1600k s plus 10 to the 6 times 10k s plus 150k over 2400k s plus 10 to the 6 times 0.2s plus 1 times 50k. Now, if you multiply top and bottom by 1 over 10 to the 6, you're going to have 1.6s plus 1 times 10k s plus 150k over, we have 2.4s plus 1, and then we have 10k s plus 50k. Now again, top and bottom by 10k, then we have 1.6s plus 1, s plus 15, 2.4s plus 1, s plus 5. That's the answer.